Welcome viewers to the series of lecture that is focused on AI. So this particular lecture is more about the machine learning and the explainable AI. So before understanding what is explainable AI, let's understand what is AI. So AI is basically the simulation of human intelligence in a computer controlled device. It means that we want to make the machine learn and behave in the human intelligence way. For example, it could be the logic that we work on, the thinking ability, the simple mathematics that we do, and the complex logic that we perform in our day-to-day life. Also, the planning activities. So, we are more into planning if we have to go out for somewhere, or maybe we are planning for creating some kind of courses for the students and all. So, everything it requires a planning. And when a plan is successful or maybe it fails, we learn from our experiences. Okay. So, from therein the word learning is coming. So, the machine has to learn from whatever activities it performs. So, maybe the activities sometimes can give good results, or you can say accurate performing results, but sometimes it may not. So, in those cases the machine has to learn, and that is what the artificial intelligence is all about. And why we do all this making the machine understand the human intelligence in form of logic and planning and learning? Because we want the system to do certain type of problem solving. There are different problems that exist in the real world, and through computer science, through artificial intelligence, data science, machine learning, deep learning, these are the activities of computers, you can say the core computer science, which are used by the technicians, the computer experts, the computer scientists to do certain kind of problem solving. Now, when it comes to AI, there is a life cycle, or you can say like we have the software development phases. So, this is also a kind of AI life cycle where there are different types of phases through which the data, the model building passes, so that whatever outcome we receive is a trained model that can be used for the purpose of problem solving of real world scenarios. So, the first stage in this particular AI life cycle is the discovery phase. So, discovery means what? It means that we have to collect the data. From where we are collecting the data? Is the source authenticate? Are we getting like enough data? Or you can say that how much data is required, the optimum data that is required, are we getting that? So, these are the questions that we answer, that we try to respond to the first phase. Once we have these questions answered, it means that we have the data in hand and it is complete enough to process and proceed ahead. Then we move to the data preparation phase. In many textbooks, you can find this as data cleaning or data processing, data pre-processing. So, at this point of time, you can take all these nomenclatures to be quite synonymous. Now, data preparation means what? We have collected the data and we know that the source from where the data is being collected is quite authenticated. Now, there could be certain problems in the error. Okay, some problems, or you can say some kind of ambiguity in the data. So, it could be like there are some missingness in the data, some values are not there which should be. So, these are called the missing values. Sometimes there are redundant values altogether. The whatever the sample is collected, it is repeated maybe once or twice or maybe more number of times. So, these are the redundant data. What else? There could be something called data mismatch in the formats. It means that maybe some attribute was supposed to be a numeric, but somehow the data got supplied in form of alphanumeric, or you can say alphabetic or character. So these are some errors, or you can say some problems with the data that needs to be handled, that needs to be eradicated rather. So when we are eradicating all these things from the existing data, we say that our data is now complete and it is clean. Now when this happens, then we move to the third phase, that is the model planning. Now model planning means that there are several models when it comes to AI. Okay? There could be recommendation models, regression models, the time series prediction models, many more models are there. So we have to now in this step identify what kind of problem we are dealing with. And then even when we are sure that okay, we are going to deal with a time series model, even then there are several time series algorithms or models available in the market. Now which one we have to choose? That may depend upon the type of data we have, or maybe for a particular type of data we can run across or you can simulate the algorithms, a number of algorithms we can just execute and want to see the performance analysis of all the models, and then we pick that particular model which is performing best for a given data. So there could be a different set of data, and again the model could be different. So it's very much data specific, okay, because the data that we collect, it has a certain kind of behavior, a trend. So based on that behavior of the data, or the trend of the data, the type of the data, or you can say the distribution of the data across different features, one has to select the model. Okay, so this is how we are planning for which model out of a set of models we are going to choose. So it is also domain specific, it is also data specific. Now once the model is planned, then we ask for ourselves as the computer scientist, or you can say computer technicians, that whether the model that has been selected is analytically sound or not. Now what does this analytically sound means? It means that whether the model is capable of producing highly accurate results. So this term accurate is a performance metric. So there are several other metrics that determines the performance of a model. So we have to now select what are the performance criteria or matrices that we should have to judge, or you can say to analyze or evaluate our model. Now once we have the model selected and the performance metrics selected, now we will move to the next phase, that is model building. Now in this phase we train the model with the existing data, and also we try to capture the performance of the model based on the performance metrics that we have chosen in the earlier stage. So time to time, you can say for each iteration or each epoch, we perform this performance analysis and try to capture what kind of matrices or what kind of accuracy or precision we are getting out from the model. So once the training of the model is done, we move to the result analysis. That is the next following step. Here we do the testing of the model and simultaneously take the data that is in form of results and try to analyze the results. Whether the results are conforming to our purpose or not. Maybe the accuracy is more, but it could be the case that the model is biased. For a particular kind of data only it is able to give the right or accurate result, otherwise it cannot. So there could be several cases where we have to analyze the post model building results, and then we try to go to the next step. Once we are satisfied that okay, the results are up to the mark, the results are proper as per the model application and the data given to us, then we move to the operationalization phase. Now, this is a kind of, you can say, a small scale real time implementation. So, when we are building the model, we are testing it, validating it, everything is done. Now, we have to see how it performs in the real world scenario. How you can say that how the people in a closed environment are responding to the model. So now we are very much interested to have the feedbacks. So this is also called the pilot deployment. So in this small scale deployment, we try to get the feedbacks from the end user. It could be the customers, or it could be the person who has actually built the model, and could be the companies at large. So now after we get positive feedback, then the model goes to the you can say for real world problem solving in the real world markets. Otherwise, if there are some shortcomings, some open challenges maybe got identified during the operationalization, then we again move to the discovery phase. That is, if there are some problems, then we try to find out why that problem was. Whether the data was insufficient, then we go for more samples collection. Whether the features that we have taken are insufficient, or the model is not appropriate. Maybe we have to try for some other models. Maybe some other performance matrices we have to identify to analyze the model. So all these things, they come into one package, or you can say one cycle, when a particular project is performed, a AI centric project. So this is all about the AI life cycle. Now let's understand what are the different AI application domains. So as we all know that AI is available to several domains, be it healthcare, finance, security, education, research, and whatnot. So in healthcare, it's needless to say, after the pandemic, we have seen so many predictive analysis has been done that what is the how long it will take for the pandemic to get over, that is the flattening of the pandemic curve, or what kind of symptoms a person is having to determine whether it is a kind of particular disease like COVID or something else, other respiratory diseases. So there could be classification problems, there could be prediction problems, many things. Similarly, in finance also there are kind of cost benefit analysis wherein AI comes into play. It could be security, to identify certain trends in the crimes pattern, to avoid, to identify early stage and then to deal with it. It could also be the education and research, wherein the you can say the analysis can be drawn from the citations that the researchers receive. Okay, so for example, if we have a citation network, then we can apply AI in form of data science as well as network science to see which all researchers are more prominent than others, or you can say which researchers have a prominent place in the research community, such that most of the cutting edge research are going through them. Through them means maybe they are authoring those papers regularly. So there are different parameters, could be how active a particular researcher is, how well connected a particular researcher is, and many more such things. Similarly, we have transportation networks where different type of you can say the traffic hotspot analysis, peak hour traffic prediction. So these things can be done. And there are other areas also, the industry, the agriculture, wherein you can do the climate prediction, climate change, analysis, and also the sports, entertainment, social media are also such kind of domains which are not untouched by AI. Okay, so these are the domains of AI. Now let's try to understand what are the different application tasks of AI. So tasks could be the prediction, maybe the prediction that we are performing, or maybe we are more interested to recommend something. So prediction could be like we are predicting the change in weather. Recommendation is something like you are recommending, you have built a model that can recommend a patient what kind of treatment he or she should go for, what kind of diagnosis is more preferred. Clustering, classification, these two are very closely related terms but has a very significant distinct context. It's like when we have the ground truth reality, like for example, we know that given a particular set of features, we are able to classify a person as, maybe you can say, an undergraduate student or a postgraduate student. It could be the number of years of his or her study, the number of subjects, the types of subjects has been taken, the internships, and many more things. That helps us to classify a particular student in a bucket of a, say, undergraduate, postgraduate, or a doctoral student or a scholar. But if we don't have the ground truth reality, that is, in the past, maybe we had kind of labels that if this was the case, if a certain set of features were there, we had classified that particular person or a student as an undergraduate. But if we don't have such a data, then we have to analyze the similarity in the characteristics or the behavior of those students and place them in a particular, or you can say a similar type of cluster. So when we are doing clustering, it means that we don't have much understanding or much information about the ground truth or the labels. And in the classification, we do have. So classification becomes a supervised kind of approach, whereas clustering becomes a unsupervised, because we don't have any ground truth reality to support our analysis. So challenges are more associated with the unsupervised methods. Then there is association rule mining, business intelligence, content generation. So these days we have seen content generation so much using the large language models. So whenever the large language models occur, it means that we are more towards processing the natural language, doing some kind of sentiment analysis, some summarization of a given content, or which keywords are more specific given to a particular content. And how association rule mining is done, it means that whenever it's very much related to the market basket analysis, where there could be cases that a person has gone to the market to buy say product 1 and product 2, and it has again a history of purchases, because the supermarkets, they have so many people going to the market and buying things. They can maintain a record of many activities, like which all products were bought together. Now given those kind of purchases, there could be some kind of trend analysis conducted to find out which pair, or you can say which 3 products or 4 products or n number of products have a stronger association. So we can find out the strong and the weak associations related to a set of items bought together. Okay. So similarly, as we have seen that AI has a very prevalent application in the industries also. So the drones and the bots, these are actually the AI application tasks that the industries get benefited out of it. Now we are in a position to understand what is XAI, that is Explainable Artificial Intelligence. We know the artificial intelligence is going to cater more human intelligence or human-like behavior to the machines. Now, what explainable AI is doing, it means that whatever the AI as a model, a method, or as an algorithm it is performing, explainable AI techniques is helping the humans, or the, you can say, the human end users, to understand why the AI model or the machine is behaving in a certain way. So you can say it is a kind of AI on the existing AI model. So it's AI over AI. So in order to understand what are the different capacities of the AI systems, we need to know that there are 4 pillars of XAI. The first one is to justify, control, then discover, and finally to improve. Now, what we are doing, this justification, controlling, discovering new things, or improving something, it is all together to understand the decision making process that the AI model is performing. So we know that we, the humans, as programmers, are building the models. Okay, so we know how the program we have done. But when we have large amount of data, then it really becomes very tough to understand that why the model behaved in a specific way. So it could be the large scale, or you can say the scalability of the data that demands explainable AI, and also it could be, you can say, the end user could be different from the one who has programmed. So it could be the different end users, it could be the customers mainly, and they want to know that why this model is giving me this kind of a prediction, why this kind of decision making is being performed by the machine. Can I trust the machine intelligence? So these questions are relevantly answered by the XAI. It also says that how much the feature contribute to model outcome. Now, before answering this question, let's try to understand in a very simplistic way that what are the features. So we have this concept of a table with rows and columns, right? So now whenever we are talking of the rows, it means that we are talking of the samples. So it could be the samples of the students performing in a set of exams. It could be the patients who are getting some treatments and have some symptoms, and many more things. So the rows, they always correspond to the type of sample we have, the samples, and the columns are nothing but the features. So for example, if in a healthcare record system, the sample is a patient, that is the row signifies a particular patient, then the feature is what? It could be the symptoms, number of days of treatment, what is the age of the person, some kind of previous ailments they have or not. So these kind of things are called the features. So how much each of the feature is going to contribute to the model performance is what XAI is going to understand. It also helps to make the model transparent, that how these features, the importance of the features can be made understandable to the end user. So we will probe more into XAI in a short while. So for now, please stay. Thank you.